power factor corrections. So the power factor corrections is to improve power factor. Power factor means power quality, which can reduce the load, electrical distribution, power distribution systems. Maybe also increase energy efficiency and its ability to reduce electrical cost, means like minimize electrical cost. So the power factor corrections could be obtained by connecting capacitor, very important, which produce reactive the power in the positions to the energy observed by a load, such as motor or locally close the road. So that improves the power factor from the point where the reactive power sources is connected, or the preventing or prohibiting this like unnecessary the circumstance in the power system network. So now we have really the simple questions for today. So that was, let's see here. Okay. This register, that is for the inductor. Okay. So the voltage source is 240 with some RMS 0, and F is the 60 Hertz. Okay. So the question 1. Okay, the question 1. What is the total impedance? Okay. So the total impedance, okay, this is X bar, 50 ohm, and X of L, the 20 ohm. Okay. So let's say, so the G sub T is R plus J X of L from this AC series circuit. So R is 50 ohm, J the 20 ohm. Okay. No 70 ohm, please. Okay. No 70 ohm. Okay. J, because that is the inductor of reactance. So now the question 2 is, what is the I sub T? Okay, I sub total RMS. So the I sub total RMS is V sub RMS divided G sub T here. Okay, so V sub RMS is source voltage right there, the 240 is RMS 0, the divided the G sub T here, G sub 20. Okay, so the finally, after skip the calculations, that was 4.46 M minus 21.8 degree. That is for total the current. Okay, this is I sub T here. Okay. All right. So the question 3. What is for active power? The active power from the circuit, that was the I square. Okay. The I square, the times the R. Okay. All right. So the I is what? 4.46 square times 50 ohm. Okay. Because the I we have already calculated from the question 2. So now that was for 994.58 watt. Okay. And the question 4 is Q is I squared times the x of L. The I squared times the x of L. Okay. So Q is the I 4.46 squared times the x of L is the 20. So after calculation, you're gonna 397.8. VAR. Don't missing the unit. Okay. Don't missing the unit. So okay. Any questions? All right. So now so Q5 is what is for S, the complex power form. Okay. So that was P plus the JQ. Okay. P we have maybe already calculated. Q we have already calculated. So 994.5 watt plus J 3978 VAR. Okay. Right. So, and question 6. Question 6. So, what maybe adding, adding a capacitor to cancel out the positive Q sub L. What is Q sub C? And what is the X sub C? And what is the C here? Okay. So go back to the circuit here, like this one. What is the C finally, because Q sub L and Q sub X sub C to the cancel out the reactive power components of this circuit. That is to improve the power factor to make a 1. Right. So right now, step by step, Q sub X sub L, starting point, step 1, to cancel out Q sub X sub L, they should be the same. Okay. So the Q sub X sub L, we have already calculated, 397.8 VAR, right? And then the Q sub X sub C is what? R V sub RMS square. Oh, I'm sorry. This is the X sub C. Why? Because can you see that right there? Let's say okay, like this. That was the V sub S. That was the V sub S. That was the V sub S. Okay. V sub S, V sub S, and then V sub S. Okay. Okay. So the Q sub X sub L is equal to Q sub X sub C. So this is why the V sub RMS square over X sub C. So V sub RMS is the 240 square over X sub C here. Okay. So now the X sub C is 397.8 over 240 square. Okay. So after calculations is what? 144.78 the ohm here. So now that is for the answer, this one. And then from here, finally, we have to find the C. What is a C? Because the x of C, 2 pi fc, 1 over c. So here, C is 2 pi f x of c, d over 1. The f from the questions here, 60 hertz, right? So go back to here. 2 pi 60, the times the x of c, like this one, 144.78 over 1. Okay, C. So now after calculation, C is the 18.32 microfarad. That is the answer.